Hi, good evening, and it's my pleasure to introduce Bob. Bob Frankston is a fellow of the IEEE, the ACM, and the Computer History Museum. He is on the board of governors of the IEEE CE Society, and he also writes the Bits versus Electrons column in the IEEE Consumer Electronics magazine. He has a master's and an engineer's degree from MIT in EE and CS, and his career has been devoted to empowering people to take advantage of computing and connectivity. He wrote the first electronic spreadsheet, VisiCalc, and while he was at Microsoft, he was instrumental in connecting home users with the rest of the internet. It's a pleasure to welcome Bob.
Okay. So I'm flexible. I can skip over slides, whatever. These are mainly to give me a hint as I figure out what I really want to say. But obviously, I'm a software person, but I learn by doing, and I treat hardware as just one more tool to use. If this doesn't work, we're going to, okay. So I'm giving these times to give a sense that things change, but everything seems to be changing so fast, but in a sense, it's not changing that fast. So I get excited by all the new products, but I also try to maintain some perspective. Now, what is consumer electronics? In the old days, we had radios and those technologies which required an ecosystem control, put together standards. And then that even became more important when we had this new concept of television. Very complex. I mean, television is an amazing engineering feat. Everything had to be just right. And we had to have big standards meetings, broadcast society, which is what the CE Society was. There's still people trying to define television standards, but that's another story. Now, what's interesting is a telephone was not considered part of consumer electronics. By the way, this is my own history. These are not official uses of the term. You can disagree if you want. But the telephone industry was a part. In the US, I know the rest of the world, you didn't own your phone. It was just a service delivery vehicle. Could you imagine not having control of these? Oh, I forgot, we don't have control of these. Oh well, things do change very slowly. Now I grew up in this world. My father manufactured, I found this on the net, this in the 1950s. This is a piece of hi-fi equipment, high fidelity, big thing those days. And you notice these days it even has a binaural and a stereo section. All these are new technologies. But what is really exciting, and now, by the way, I still have, this is taken just this week. But if you look behind here, you see those connectors. These are components, and you would start to interconnect them yourselves. You get best of the breed, and you use a wire to define the relationships. So the scary part is we still do that. We still have these plug boards behind. We run wires to connect things. As I said, things change very, very slowly. But what's exciting about this is that as a consumer, you aren't just a consumer. The problem is that the word has started to change meanings. You actually produce things. In English, there's a term contronym, which is a word that has its own antonym. So a consumer doesn't just consume, but a consumer these days produces and makes things. And as things have become more powerful. Now, I learn a lot from home control because it's a scale where I can experiment myself. And my IT staff is often busy, but when you have to complain to yourself, there's a limit to what you can do. So a lot of this is called home automation. All this new technology, but home automation is a really bad model. You don't want to be automated, have your house be smarter than you are. So a lot of this is what I call the trophy home market. If you notice, this is an ad I found on the web, and look at that house. Now, how many of you have a house like that? Now, of course, you can have a real trophy home. I assume you recognize this picture. And they probably have a very big IT staff to maintain the homes. But I think of consumer electronics on the scale of things you can do yourself, and that's what makes it interesting. Now, how many of you know about research on a company called Spacely Sprockets? You ever heard of Spacely Sprockets? Have you heard of the Jetsons? George Jetson worked in spacely sprockets. And that's really the pattern for today's smart home. I mean, now, there are a lot of exciting things about voice and Siri, but a lot of it comes from the idea that you should be able to talk to your kitchen or your robot maid and have it make pizza for you, very fixed scripts. And in some sense, by the way, if you look behind Alexa, it's not really intelligent. It's just got it's like a chef, an automated chef with a big menu. It's not very intelligent. Now, given, I should be looking at the time, given a lot of time, I go through the whole history of home control in detail, but how many of you know about X10? Nobody. It used to be the center of home control. That it was invented in 1975, basically by a company called Pico Electronics to turn things on and off. And initial use was to turn and off phonographs. How many of you know what a phonograph or record player is? Some of you still remember those technologies. Now, it's interesting because it was a peer-connected technology. And the reason it lasted so well is that it did something very simple, just turn things on and off, which is about the most generic building block you can have. So it was a very exciting center of home control. And it was cheap to make in those days. It used power line signaling, all sorts of techniques. So I started basically in the 1980s, 1990s to play with it. And I started to get some devices to allow me to interconnect with my computer. I was trying to do the slides a little differently. Now, there were some, even with the simple X10, there's some powerful lessons I learned. How do you design a system that's not reliable? And I used my family as a beta site. Not always willingly. I didn't want my kids to know that in their friend's house, if you turn the light on, the lights went on. In my house, they probably went on, but you learn to live with it, and you learn to program around such failures. You really get a lesson in resilience. There's also a side effect of extra complication in the code. This will eventually get to the next slide. If it doesn't, we go back to plan A. I don't know. These new technologies. I have fun, by the way, playing with these new technologies. The fact they don't work makes it actually more fun. But the key thing, if I ever figure out how to make this work, is that I do not want an automated home. I want a home I can control. For a number of reasons. One, I want to be in control. If you move the furniture, I don't have to call an installer to change the behavior of the light switch. I have a friend who was complaining that he had to live with the house the way it is because he lost the control disk, and that's the way it is. When you want to wake up early in the morning, you don't have to call the installer. So part of my principle is you want to be able to do it yourself, but as you said, I want to empower other people to do it myself. So I'm trying to do things in a way that can be shared with other people. So I took that thinking in 1995, when I was in Microsoft, I was working from home, and basically I had a home network. Now in those days, the idea of people running their own networks was unheard of. You need a professional IT staff. And I knew that networking, there's nothing really complicated about networks, at least small networks, or shouldn't be. So, and in those days, and we're going to get to this in the second part of the talk, networking was a service. Basically, it was like the days of dial-up modems. Every time you got a new computer, like in the old days, if you have two phone lines at home, you pay for two phone calls, two phone lines. Now, we still do that today, even though they're virtual phone lines. They've conned us into paying for them. But by putting the router, or NAT, if you're more technical, at the edge of the house, I gave people control over the networking. So that broadband pipe coming into your house was no longer a service delivery pipe by the part of the phone companies. It was the way you became a peer with the rest of the internet. And that, I think, really helped sort of usher in an age of connectivity. It wasn't just the internet, it wasn't just something you dialed up once in a while, but you're a full participant. And again, the same constraint, no installers. And that became standard in Windows 98 SE. You probably never even heard of that. There was a days when Windows 95, Windows 3, in any case. But the main thing was Windows became ready to be connected. It enabled you to buy the router NAT and have it just work. Could you imagine if you had to manually assign IP addresses and all this? And if you had to pay for a monthly fee for each printer? So I try to apply these lessons to sort of home control. There was something called Home Plug and Play group I was working. And where it was important to me is it started to make me understand the internet a lot better. Today's internet has some real problems. It's actually still too smart. You still need to get an IP address from somebody. And one of the lessons I learned from this is you need stable relationships. The relationship between the light switch and the light fixture at the time had to be stable. The IP address is not a stable identifier. And what's worse, the DNS name, the .com names or the .in names are not stable. You don't own those names. That's a fatal flaw. I've compared it with holding the web together with surgical thread. So these are lessons like scripting. Again, I'm going through this quickly because I'm trying to compress a talk and a half into the slot. And you're also very hungry. But the lesson was all these smart homes, automation, scripting, these things don't scale. We have multiple people in the house, they won't agree. And how many people programmers anyway? So you learned that you want to describe intent, and it's sort of, as you try to give other people power, you got to figure out how to make it, consumer and usable and maintainable. When you come home to your house and the lights start flashing, you don't have to debug it. There are other lessons like hierarchies don't work. Everybody's like smart home and HomeKit, these are part of a hierarchy. Well, the driveway might be shared. So you need to rethink a lot of the control mechanisms. And also, security is the wrong model. Because who do you trust? Now, there are people who you'll trust with your life, but not with your money. So it's not well ordered. So there are lots of attempts to make the network smarter. There was CE bus. They thought maybe the network should be smarter. So there was CE bus, and that failed. You probably never even heard of it. You might have heard of Zigbee and Z-Wave. You might have heard of IEEE 1394, which totally failed. It seemed like the future dominates CES for year after year. IEEE 1394, Firewire, until it disappeared. Because it was too TDS, too damn smart. And that's the lesson. If you put, you're constrained by having the smarts in the network. These days, if I can get the latest version is Bluetooth, where you need to do a new chip for every new protocol. Something wrong with this. There's something called Bluetooth Mesh, which is reinventing the internet. So again and again, people need to learn this lesson, and I'm going to get to this in the second lesson, of the internet, not as the internet, big letters, but the architectural concepts behind the internet. There's just a little side. I was asked to do a thing called Universal Plug and Play. They didn't like my design. So instead, they went with a smart design. And as many of you know, DLNA and things, they sort of use, but they don't really solve the problem. Okay. I just had to get that out because, damn it, they should have taken my design. So back to the home control. So I did learn a lot from a thing called Insteon, which took the principle of, so much for this technology. Come on. Next slide. Alexa, next slide. Oh, I didn't program that. Well, I can always click here. Oops. Now I need to go back. Okay. So Insteon basically was like X10, except it had stable relationship between endpoints, but it was a large address. And it performed much more reliably and had many more devices. Now, one other part, by the way, about home control is you don't just send commands. I want to observe the state change. I want to, if I turn a light on, I want to see it reflected in my controller. So these, again, Insteon gave me enough capability so I can actually start to replace essentially all the switches in my house. So as far as I know, I've got 0 conventional switches left in my house. And I have a few fluorescents, but they're all LED lights and getting smart now. But now the question is, why do I do this? And it's because to put me in control. These should be mundane, simple to use. And I'm going to get to one lesson because, yeah, I'll just hit this. So won't go on the limits of Insteon. One other thing, by the way, another technology is SmartThings, which is bought by Samsung. And this gets back to some of the lessons of networking. How do you make money in home control? You add value. How do you add value to light switches? It's simple stuff. You put a big rules engine in the middle. So you have to program around that, because who wants your house to depend on some rule engine running who knows where, Tierra del Fuego or Tasmania? Everything in your house should be controlled locally. So part of the challenge I have is simulating a simple architecture even when I'm using things, even when people do me favors I don't want. So my software's continued to evolve, and I've had to clean up a lot of the code and everything. So here's where another set of lessons. I'm now using HTML5, or what I call, how many of you are familiar with progressive web apps? That basically use the browser as your engine, which is very powerful, very nice, well, not perfectly nice, it's getting there, environment. And the nice thing is I can also now shift more, I can now have I basically buy $30 tablets, put them on the wall, using it. How many of you heard of 3M command strips? Basically, it's removable Velcro. So I can just glue things to the wall and move them, which is it's not just in software I want a lot of flexibility, I want the flexibility in hardware. So a lot of lessons, I guess you're not seeing the colors here, but it was really a lesson. How do you provide feedback? How do you say half the lights are on? How do you do control? So it's a whole long discussion, and it can also program. One interesting lesson, I started out by programming a house view. Turns out it's too complicated to see those little buttons. People can read words and learn that. Now, and I've also been experimenting. Recently, I used IFTT, which again doesn't scale, but at least I can tell Alexa now to turn my lights on. And what I discovered is actually voice is useful. When your hands are full, you can turn the lights on, but I couldn't use Alexa directly because I've got too many devices, and Alexa itself doesn't scale, so I had to put in my own shims. Yeah, one day this technology will work. Now, more recently, I've been using IP-based LED light bulbs. Now, the nice thing about the LIFX bulbs, these are IP-based, which means that, now one thing I did on the side was I beefed up my Wi-Fi more than I'd like to, because I won't go into all the problems with Wi-Fi protocol, security, a lot of things. There's a lot of compromise here. In a longer talk, I can go into much more detail about the security trust models. But at least these bulbs are just on the local network. I control them in theory, locally. And the big shift has been the devices themselves are the endpoints. And you discover things. Turns out, how many of you know about temperature for lights? The difference between 3,500 Kelvin and 5,000 Kelvin. Turns out that it's nice. My wife was complaining about the kitchen. I was able to make the kitchen lights look good by saying, okay, the kitchen should be 3,500 Kelvin, which is considered a cool light. My office, I can choose daylight. You discover these new possibilities. Now, and also, it's, again, not just automating my lights. You can start to innovate in new directions, like these light panels from a company called Nanoleaf, and LIFX will offer them. You can start to forget bulbs. Just have light panels on the wall. So we're just I gave you that a long time. All this things change slowly, but they also change quickly because we're not simply automating the old technology, we're discovering new possibilities, new degrees of freedom. So everything is changing at once, and you're learning to take advantage of the opportunities. This is part of what's experimenting. Until you live it, you don't really appreciate this. But there's also a downside. At the beginning, I gave a talk in 1997 at the IEEE, something like this, in Singapore, saying we need open APIs and things. Now I've got them, and everybody's doing apps. Every device has its own apps. I hate that. This is why I want progressive web apps, web pages, but I really want APIs so I can unify them. This is part of, again, in consumer electronics, we don't necessarily want, sell point solutions. That was the old days. This is why I started with the component hi-fi systems. We're learning how to build systems, not just, I hate the term IoT, but to use it, now that we have intelligence on devices, how do we composite into a new whole? How do we put that together? And that's what's going to spend the next 50 years figuring out. But we're going to do it, immediately start using it. And there's a thing called this cloud, which is, we used to call time sharing. The thing is, you don't want your house to depend on the cloud. It should work even if you don't have a connection, but you could use it to enhance things. So you could have enhancements. Another architectural lesson is, where do you have the dependencies? Now, in terms of the industry, there's one of the big changes that software has wrought at the internet. And again, when I talk about the internet, I don't mean the internet, this thing you access, social network. I'm talking about the ideas behind it. So in my column, which just came out, how many of you get the IEEE, the CE magazine? Well, join the society and get it, in any case. I explained that I ran across this book called DVD Mystified. It was written at a time when there was some uncertainty about whether DVDs would catch on. Because DVDs required an entire new industry. Everything had to change, just like HGTV. The entire broadcast industry had to replace all its gears. And that's the big change now, is in software. You want a new format? Fine, just implement it. It just works. And that's, again, a change at the industry. This is the problem I have with 5G, ATSC. They think we need a new network for new technologies. You need a new network for IoT. It's great for the network people. They want to sell gears, but it's not reality. One other lesson is I want to go into is meta devices. But okay, so for the first part of the talk, so the challenges we face. We do need new hardware building blocks. And that's a problem because things become generic right away. So for me, this is a nice building block. I basically, again, so this is a real live light switch in my house. Okay, I really turned on my office light just now. So this is very powerful, but there are form factors, there are other things, sensors. And again, this is a long discussion about pure sensors by themselves aren't great for software building blocks, but it's becoming very inexpensive to package them up. So this is where I want to see a lot of hardware innovation in enabling technologies. The problem is that if I want to build things on top of them, will the people manufacturing them get enough value to justify it? So this is part of the problem right now, is generic hardware does not have huge margins. So, but if they let me add the value, they don't get the margins to build it. If they keep the value, I don't get the flexibility I want. So this is the fun part we're going through. There's another problem we have, I'll get to it, is software is never finished, but companies are. So your device is going to outlive your ability to maintain the software. Many issues we're going to come to terms with. So I went through some of this. So just some observations for this part. The home control is hard to explain. It's mundane utility. The idea that in order to make a change, I've got to run a wire is very strange to me. I should just put up a light switch, glue it on the wall, or just this, and define what it does. And if I want to change it, I change it. Now, in my room, there's a master switch. I'm thinking of all the complicated wiring the hotel did and everything. It should just be in software, be able to set it up, maybe authorize me to use my own device to control the room. It's a different way of thinking than have everything planned ahead. How do you make it possible? And some of this is happening. A lot of hotels now, you go in, and you can indeed use your phone, or, sorry, you're going to try to explain to kids why is it called a phone. Because the word phone, it comes from its Latin or the Greek word for sound, and what does that have to do with these devices? But again, that's the way language works. We still film. We're still filming. How many people know why it was called film? But again, that's the fun of it. But it's the ability, instead of having to do something crude like pull a plug out of the wall or have a wire which cuts it, you just specify the relationship, and I'm going to get to that. An example of the problem, here I just found myself at the airport wanting to get a drink. And there was a WinCE machine that was decided to update. Do I wait for the update before getting my plane? These are things you have to figure out. You're living in your house, it decides to reboot. Actually, I'm sure you've been on planes where the pilot says, sorry, we're going to reboot the plane. No, that happens. They do this. Or you want to watch TV. You run into this. And it depends on how things go wrong. Like, how many of you on the screens outside these rooms wonder why it's not full screen? A lot of people using this technology, part of us as an industry should think about, look at the failure modes when you look around. I remember at a fast food place in the airport, there was a big display, and one item isn't available, and there's a piece of tape over it. But nobody could figure out how to change the display, so here have the electronic display with a piece of tape over it. Okay, so the next talk, which actually we're running ahead of schedule, which is, well, no, not that ahead of schedule. Okay, the next talk, and this is my mail, and UPS. Who knows what embarrassing things are on here? So we better hide it by going to the next talk, which is this one. Okay, and if I figure out how to press F5, there. So now, if we're going to connect the devices, we need infrastructure to connect. And now this is not just consumer, but this is industrial, societal, as our new infrastructure. So traditional telecom, basically we paid for services. A simple model, it was like railroads, you need channels to keep the bits intact, the messages. Telephony only worked because we had everything was reserved so we could maintain the strict isochronous system. Video, it is amazing that television works at all. Microsecond timing in the 1930s? What is Philip Farnsworth thinking? It must have been crazy. Well, he did go crazy, but that was because of Sarnoff and RCA. We don't need to relive old battles. So that was one industry, was this channel-based broadcast industry. The other part of the industry was channel-based streams. The other was broadcasting, where it came up with strange ideas like turning radio frequencies into properties, because he used some very bad algorithms like single frequency signaling. But the whole industry, the business model, like at CS, I tried to ask about radios, and they were very confused. But for them, radio was music. This is CS, Consumer Electronics Show. For them, radio meant the business of music. So all these things are tied together, which makes it hard to talk about, because the words we use assume the business model of telecom, assume the business model like with radio. Now, in the 1970s, this new digital stuff came in. And of course, Claude Shannon worked on a lot of digital research, which gave us computers, which killed the industry. But how many of you know what Claude Shannon meant when he said information? People talk about Claude Shannon saying there are only so many radio stations, something. No, he uses the word for entropy. It was not physics, so ignore that. But the phone companies, because they were confused, wanted to get the information services because, well, they want to own the value inside the network. This is one of the big battles. How many of you are familiar with Minitel? How many of you are awake? Okay. Minitel was in France. They gave everybody. You see, I have to realize, not all of you remember Minitel happening. It gave everybody in France a computer terminal, which was wonderful, really advanced, or so it seemed. Turns out it was the old telco model of being owned by the phone company. But that was sort of the height of the industry. Then they broke up AT&T. So the historic model is they added value by taking responsibility for delivery of content. It's just like the post office. All those messages, like telegrams, basically, phone calls used to be measured in message units. What's a message unit? It's a telegram. And we now have another word for message unit, which is called a minute. Those minutes are still 19th century telegrams. Very strange. But that's the business model. The value is created in the network. And just like a railroad owned the rails as its infrastructure for exclusive use, phone companies own the wires. They had reserved resources, so in order to make, this is why the video calls, even though the telephone company was demonstrating video calls in the 1960s, it never became a business because in order to guarantee it worked, they had to reserve capacity. And that was expensive, so it was too expensive to do. The reason you have video now is because you don't promise it. And if you don't promise it, it's fine if it doesn't work, but it's great if it works. So this is part of why it's so hard for the traditional telephone companies to think in terms of the internet. Because instead of making promises, we're creating opportunities. And by accepting the risk of failure, we can take advantage of the success. Now, what's broadband? Broadband, okay, you're double E's, right? At least some of you are. Broadband is a broadcast, large bands. When you take those wide bands, you put them on a coaxial cable, those are broadband cables. So that's why cable TV became broadband, because they were relaying broadband cables. Then they realized, like a road, they own the medium. They can start new businesses. So this is why people call the internet broadband, because we repurposed an existing technology. We kept the same name, even though we connect despite them. So I talked about home network earlier. The big discovery is packet radio. With packet radios, people figured out how to do networking without a network. Because a packet radio, the computer would just throw up a packet, and if it landed, great, you got it. If it got lost, got lost. We had computers at both ends. We could program around that, and that's really the theme here. We can basically retry. Very simple algorithm. But the other part of it was that in the days of telegrams, it was one way. You carry postal message, you had to guarantee delivery. This was a conversation. Instead of having to guarantee the packet gets through, you can ask, did you get it? No, I'll send it again. A very simple idea, but very powerful. And then kid in class next to me was using, said, why don't you take Aloha Net, which is the packet net put on a coaxial cable, he called it Ethernet. There was no provider. It was a baseband network. I wanted to put on the campus network in 1973, but it never carried through, so I can't claim credit for broadband. Now, what's exciting about the Internetworking Initiative, which you might know as the Internet, is that it accepted that constraint. That there was nobody that the guarantee packets went through. And the packets were not part of circuits, they were independent. And I'm going to explain that. You simply tagged each packet, sent it through. If it got there, fine. If it didn't, it didn't. It was more sophisticated than Ethernet because it used a protocol, transmission control protocol. So if the network was congested, you lost packets, it would slow down. And this is part of the magic, that it's dynamic cooperation. So the genius was in accepting that constraint and realizing that, so what if we can't do voice? We'll do what works. The big surprise in the 1990s, when even the people who developed the VoIP protocol discovered people using it on the net. It worked, it was a surprise. It did not come from trying to make telephony work. It just accidentally worked. So to understand how the internet it differs from telecom, think about how things work in telecom. If I want to get a picture of Mickey, take a moment of silence for the late Mickey, the packets had to go precise order. They were scanned, sent precisely through the network, isochronously, perfectly, reached the other end, and got assembled. Now with software, we don't have to do that. The packets can take any route they want. You lose a few, it doesn't matter. We assemble them ourselves and then put them together. That's very different. And we can go a step further. Oops. Oh well, wrong sizes. We can, we don't even have to send the picture. I can send a drawing. In other words, we don't have to have this perfect match. We have all this new ways we can discover and accomplish things. So I talked about, and the term for that is best effort, since we don't rely on the packets getting through. So I can go through, think about the internet as these packets, not streams, are all going independently. Now, the other part of this is architecture, very important. So I was experimenting, I wrote about this in one of my columns. So we have two boards. They want to communicate with each other. So the architecture is a very simple wire. All they do is they worry about connecting the other end and think about nothing else. So as a programmer, that's very simple. I don't worry about all that stuff in the middle. I just send a message. Now the reality is there might be a router in the path, or NAT, this kludges. There might be the entire telecommunication industry between the two endpoints. It doesn't matter. I've taken the entire multi-trillion-dollar telecommunication industry and treated it just like a piece of copper. It's just there. Now that has interesting implications. We have to think not in terms of layers and dependency, but simply this powerful idea that we could focus on relationships. And you taught all these layers. Forget the ISO stack. That's a story we tell children to confuse them. Now, I did learn about ISO a long time ago because, just to give you a sense of how long ago, the reason I remember the talk, I think in 1965, was the slides kept melting, and he had to talk fast to explain it. So that's how long ago. But it's a reference model. It's not reality. Now, this breaks when you stick something in the middle. You have a pure API, but if you have a telephone company or some rent seeker or paywall in the middle, it breaks. Now, I already went through this need to get a separate industry per technology. So for policy, we need generic building blocks infrastructure, and we need to make sure connectivity works without having somebody in the middle here to negotiate with. Now you aren't buying services, so we need a different approach. And the reason I call it infrastructure, not a utility, is utility we think somebody's in the middle of a measure consuming something. Infrastructure is more like sidewalks. It's just there. We create the value. An important part is that it's free to use. Now, free to use doesn't mean it's free. It's paid for in a way that does not prevent us from taking advantage of value. This is the great enabler for innovation. It enables you to create new industries because it becomes a resource to use. And that's really the change we're going through right now. We need to switch from seeing the internet as a bunch of services, or, again, in India it's very useful to use the elephant, the blind man and the elephant. But it's not a social network, it's not that. What we really want to do is create opportunity. And then we use software to take advantage of that opportunity to make it what we want. And how do we get more things? We don't try to access, there's no someplace we access. That's an old telecom term. We don't want a freemium upsell where we'll give away free basics in order to get you to buy cellular. Now, free basics by itself is not a terrible thing, but it's pretty agnostic. The problem is it's locked into the model of access. So the alternative is to make it a community resource, something where connecting to the world is just an option, but there's still local value to get to that. The term I use is ambient connectivity. which means I can just assume connectivity. Think of Wi-Fi everywhere, no billing, it just works. You don't have to put your hotel room, I mean, every place, this hotel room, I mean, it's absurd. You can usually get connectivity, but each place, so you can't build medical monitors based on that. Now, the subtle thing, because I'm speaking to a technical audience, is architecturally you assume it's there. We've decoupled the problem of how do you assure it's there. So you might be in an area where there's no connectivity, but you don't put a special thing yourself, you just put in generic connectivity, and then everybody benefits. This is really why for emergency services, it's wonderful. The problem is you also need more dynamic protocols, but that's a longer discussion. So in practice, we have a model where you do it yourself. So your home network, you do it yourself, you're in full control. The reason we've stalled there is the next stage is I call it do it ourselves. We need to cooperate. Now, we can have the government say, we'll make an infrastructure, make it available free. And for those of you who try to get the government to understand things, it's not a very fruitful approach, though I try. Instead, you start with like apartment complexes or villages where you make it a resource. Now, in the US, I talk about apartment complexes as the main thing, and I think that is important sort of as a first world example. But in India, where you're trying to connect remote villages, instead of saying we're going to put up balloons and all this kind of stuff, I mean, drones and balloons are fun. You know, don't get me wrong on that. But don't confuse that with solving the world's economic problems. Instead, we realize connectivity is a concept useful by itself. So yeah, you don't have to connect people to the world for it to be useful. Again, fiber is very important because the donkeys need to be fed. And then it becomes a community resource. You're speaking to people here working on actually projects like crop management, connected or drones, which is still useful in a village, even if it's not connected to the world. It has value. And when you aggregate your connectivity, especially work with adjacent communities, even if you're poor, you start to get enough resource to get a connection to the world. In the idea that you have to get a cellular company has to make a profit, then it's like you're not going to put roads there because they can't afford a high toll. No, you build this infrastructure and you create value and wealth by building the infrastructure, but you don't want to say it's just about connecting to. Basically, the goal is not to connect remote villages to Facebook. That might be a byproduct, but that's not the goal. The goal is to basically take advantage of the technology locally, connect like medical connectivity, might be connect crops, could be any number of those purposes, or connect, or even a local social network is useful. One thing here is medical monitors should be very simple on the watch, but we don't have it because it doesn't generate enough traffic to make the phone companies happy. So people die because we have a gatekeeper who must make a profit. A different business model where it's community-owned infrastructure doesn't have that problem and is very generative. The other part was application program interfaces. So you look at these boards at a train station, that's fine. That's Mumbai. And maps, but all these are possible because you have APIs. In a sense, initial API was Route 1 in the US. You just put up signs saying this is wrong. We didn't build it. But now those train schedules, you're more likely to look at it on your phone. So it's not just issue of connectivity. We now need to create enabling infrastructure so we can define the world in software. And the reason I call it consumer electronics is these are consumer products. Not just consumer products, but individuals now are sort of doing peer production. They're creating apps, websites, using APIs to provide city data. And some of which turn to businesses, some which don't, but that's okay. Now, we're still learning how to do it, but instead of smart cities, we want empowering cities. We want to create technology for people to use. And there are dangers. We used to, in the US, think, okay, these people, they won't understand this new technology. Turns out, I won't even explain my embarrassment. And that's a whole new literacy for dealing with this world, which is a deeper topic. How do you understand how to do software? How do you understand software? Not as a mechanical skill, like Writing, don't confuse writing with typing. Typing is a mechanical skill. Coding and programming, mechanical skills. Understanding how to work in this new world, understanding the importance of architecture, understanding concepts like binding are part of this new literacy. But it's going to take a long time, so I just want to really start the conversation now. And the main thing is be resilient. Things are going to break. Design things assuming they're going to break, and if they work, you're lucky. If you have brittle dependencies, and if they break, you're out of luck. So, in any case, have fun playing with the technologies, and you have more fun eating. It's time for dinner. Oh, questions. Right? Who wants? Any questions? Anybody awake? Yes.
Do you propose that for countries?
Speak louder. Pass the mic around.
Thank you for your philosophical talk.
Turn the mic on, even better. Okay.
Thank you for your talk. It was I found it quite philosophical. Like you mentioned, do you mean that for countries like India, just as water and electricity are the utilities which government provides, internet should also be one of the utilities?
No, the internet should be infrastructure. I distinguish it between, it's basically something that's just there. A utility is measured and somebody has to provide it. The internet we create ourselves by using the technologies, and we just need to make sure there's somebody in the middle, just like who maintains the roads, to help forward the packets. It's a much simpler task. Now, as I said, the current architecture is still centralized, still providers, but over time will evolve into more peer connectivity.
So you mean the government should be doing the job of providing infrastructure?
Government at scale. So if you're an apartment house, the building can do it for itself. But when people talk about the government, there's this top-down, some omniscient provider. No, I think of the government in this sense as simply the way we coordinate. So the village council might be, the apartment house group, whatever. So it really comes from the edge, there's no edge, but from the endpoints of the edge. And interconnects. So the government in that sense is more the coordinator, might provide spanning things. So it should be paying for the undersea cables across the oceans. Right now, the problem with undersea cables, if there's too much capacity, companies like Global Crossing go bankrupt. That's a bad model. You don't want a model that requires scarcity to be viable. So governments do have a role at scale. Like the national highways, the national government does. Your driveway, you do.
Right. Thank you.
Anybody else awake? I'll ask you questions if you don't.
Bob, you mentioned about the government giving access to, for example, the air channels, the radio channels.
Well, the radio channels are an obsolete concept. The economics of those will go away. This is the thing Nicholas Nagger pointed out. Radio used to be the way to communicate over distance. Now radio, like Wi-Fi, is just a way to get to the nearest fiber or wire. And over the distance, you've got that infrastructure. Now, some places you can use radio links. But you have to rethink radio. The old radio was based on tuning forks. We now understand rich signaling, there's ultra-wideband, there are all these techniques. So the idea of radio frequencies being property is going to go away, because there won't be any value in owning it. But initially, we just want to make sure I think local ultra-wideband will replace local Wi-Fi, but for now, local Wi-Fi is a good start.
Yeah, my question was, so from a government's perspective, from a policy perspective, it makes sense to monetize the available spectrum so that you're in turn giving it back to the public. Wouldn't that be the case?
No, it doesn't. Because spectrum is a construct. It's a stupid construct. So that's like monetizing paint by licensing yellow. It should just be freely. You don't need somebody to regulate the use of color. I mean, we're in a transition. We still have got a lot of terrible technology. And give you the lecture on why spectrum allocation is a dumb idea. But it's going to fade away. But initially, I think, the simple way of thinking about it is, if you use a technology like Wi-Fi locally, all you need to do is hop to the nearest tower and it's available. You won't have private companies owning spectrum.
So what you're proposing is a bottoms-up approach versus a tops-down approach.
The bottom approach is you start like with villages or apartment houses owning the connectivity, and the economic model of ownership is very powerful. First, if you, in the US, if you get a commercial pipe into a building, it'll be a fraction the cost of the retail. So if the building owns the pipe, which is really a tunnel through telecom, they're compelling market advantages. You can think of telecom, remember somebody was talking about connecting some islands to San Francisco, and said it cost $10,000, and I was waiting for per month. There was no per month. You paid for it once, you owned it. So you know, if you join together with your neighbors, the village, whatever, you pay for the infrastructure once, you own it. There's no monthly fee anymore. Think about that. That, in a sense, telecom is a loan you can never pay off. So it's a much more rational financing model. And as you get these areas of owned connectivity with tunnels through telecom, what you leverage, you don't have to bypass them. It's a make-buy. You can buy the capacity cheap. And as the balance shifts to these owned areas, at some point the telco guys will say, please save us. Take our wires away. And you're going to infrastructure just become the norm, because it's like a home network. How many people here would pay a monthly fee for each device in the home? For each IP printer, for each PC and everything, but you don't. You can't go back once you've discovered the power of owning it.
Hi, Bob. Just more to generalize the question, or to have like what are the takeaway from your elaborate keynote? What is that maybe 1-2 takeaways what everybody can take
But I guess if I do one takeaways, one is you learn a lot by actually implementing and doing this. But I'll admit that it does have to have a lot of background. But you can still, you look for empowerment and how you can build things. So that's one takeaway. But the more important takeaway is we do have to shift to sort of think about the not as networks or anything, as a new infrastructure where you can now build things by just working the endpoints and assuming everything in the middle, just you don't have to think about it. It's just there. And that architecture concept is powerful, and we haven't begun to see how transformational it can be.
Okay, thank you.
I would like to call upon Mr. Prabin Sundaresan onto the dais for presenting the memento to Mr. Bob Frankston as a token of appreciation.